part relating to winter.
Yeah, true. I think I should turn on the AC.
How?
Yeah.
I can't afford it. The bills are too expensive.
Really?
What? You don't know the students from Heriot what actually proposed an energy conservation method which can save you some money?
Yeah, I think you should actually take a look at it.
Yes.
Our campus is located in United Arab Emirates, Dubai, being one of the major universities in Knowledge Village. Knowledge Village being a hub of multiple institutions as well as a ground for student community spaces, along with several added general and public services. The Heriot campus has a total area of around 15,280 square meters. It is an educational institute with several graduate, undergraduate, postgraduate programs with around 4,000 students. The building has multiple applied energy saving features ranging from existing features around Heriot campus include the Knowledge Village blocks, mainly Block 8, having opening to multiple other universities as well as an open ground with a Philly Cafe, the Knowledge Village public parking, the Wollongong University.
Let's learn through Heriot Watt's existing services. This is an outdoor area where there are planter box which host benches for people to sit, enjoy and play. This connects into an outdoor area which is an interspace between the lift, the cafeteria and the main entrance lobby. This leads to a main entrance and the lobby connecting to the reception area. It is a double-heighted space which also has service gates to let students admit in. This is a part of reception and lobby which is actually caught by jalousie window to provide calm and shade while working. It is a linear core of services for building and maintenance which forms a major part of the circulation for the university. This is student hub where most of the interaction between students, teachers and other colleagues happen. It has high footfall since it has been occupied throughout the day. This is library where the equipment use is very high due to study reading purposes. This is normal classroom with smart lighting systems for teaching and learning purposes. This is smart classroom where everything is provided with laptop sockets and equipment chargers. The university follows the exposed duct system throughout where we can see ducts, services, fire pipes and other different options. This shows different speakers, automated sensors and other lighting systems to let the functions carry out.
The solar studies show how the university building interacts with the sun throughout the year and on notable days like the summer and winter solstices, which are respectively the longest and shortest days of the year, as well as the spring and fall equinoxes, which are in between transitionary phases. We also show year-long studies at different times of the day to show how the sun paths go through seasonal changes. For example, in the summer, the sun will be higher up in the sky, while in winter it will be at a much lower angle. These sun paths are important to study throughout different times of the day, throughout the year, in order for the building to interact and respond effectively to the sun.
Winds were analyzed at 10 meter above ground level, which showed around 7 to 10 meter per second as the typical high-speed winds. These winds were actually dominated by the north and the northwest winds. Out of all the days in the week, high wind gusts flew on August 1st Saturday area between 14 to 19 hours GMT plus 04. This will in return generate the corresponding high energy. Considering the passive design strategies, tensile membrane shading have been generated for the car parks, and also EV charging stations have been placed with solar panels on top to promote sustainability in the university.
How did you guys decide on how to use these?
Okay, so based on the pre-existing conditions on the site, we looked into the energy requirements of the building.
And we considered this consumption and did further calculations. They are as follows.
Occupancy analysis. Comparison of the occupancy load is done with ASHRAE benchmark in mind for the three major spaces. Student hub. Here the occupancy load for student hub of around 150 meters square is measured at different periods of time. Office building. The density tends to peak above the recommended ASHRAE density during early hours from 10 a.m. to 12 a.m. The first floor cafeteria is also being compared, accounting for the entire space by the occupant load factor of 1.
These SIPC benchmarks show standard practices and then better efficient practices of energy consumption in a building.
As we can see, the total electricity and water consumptions of summer months were gathered, and it appears that on the 8th and 9th of August, electricity and water consumptions were at this peak, and this can be due to construction patterns before opening the doors for students in September. Whereas it appears that in winter months, it's pointed out that between the 22nd and 23rd as well as 28th of January, the peak of electricity appears, and this can be because of heavy attendance in the second semester. The graph shows in summer, and especially in August, CHW was almost taking 3/4 of the electricity consumption, while in fall-winter season, the CHW and electricity consumption decreased to reach the lowest in January. The graphs illustrate that heat pumps weren't working in the full capacity when in summer, but rather in winter. At the graph, the comparison of Heriot Watt against Econ 19 benchmarks of air-conditioned prestigious building, it appears that Heriot Watt University have the lowest electrical consumption when compared to typical prestigious buildings, as well as the good practice prestigious buildings.
Consumption is not going to stay the same, so how do we intend on reducing it?
Oh, it's not just about calculating the consumptions, but
Actually, there are many smart techniques which the students have proposed. Let's take a look at it.
Peak distribution. This strategy includes shifting to off-peak hours so that none of it is run ever on the same time. This leads to reducing the strain on national grid using such effective strategies. Peak shrinking involves strategies. Smart technologies, energy-saving systems, and efficient lightings have been used, all of which leads to efficient energy savings and an overall of 70% savings in an institution. Peak shaving. These strategies include reduction by using innovative systems like wind, solar, CCH.
What about saving energy?
It's not just about it, it's just a smaller part of a bigger picture. Actually, the students have suggested more innovative methods to save more energy. Let's take a look at it.
Electricity generation through wind turbines. We are using vertical axis wind turbine since for residential use and it is insensitive to wind direction. We are using almost 22 on the rooftop. On a high speed day, it generates 20.4 kilowatts hour, whereas on low speed day, it generates 9.899. On an average, it generates around 10,000 kilowatt hour on a monthly basis, which means it saves around 5.5% in energy savings in month of August. For the principle and working, it is mounted with a rotor and a gearbox where it's carried into energy system and suspended over rooftop with steel frame.
For our university building, we will be using SunPower Maxion 6 photovoltaic panels. It has a power rating of 440 watts and an efficiency of 22.8%. Our campus gets about 9.3 hours of sunlight on average, so that's roughly 700 watt hours per panel. Knowing that it costs 0.25 dirhams per kilowatt hour, with 806 panels we can expect 205,000 kilowatt hours of annual energy yield, 8 years of return investment, and a total cost of 413,000 dirhams with installation fees. Because there is limited space on the roof alone to fit all the panels that we need, an additional roof is proposed to account for the extra panel. The reinforced steel structure will cover an area of 1,330 square meters. The roof will be manufactured to be easily dismantled and reconstructed to avoid contact with the existing HVAC systems and water pumps.
Reversible heat pumps can supply heating or air conditioning to the indoor space in either direction. Heat released by the building is been absorbed by air handling unit. The heat has been sent to heat pump where heat from outside is also being absorbed. When heat pump absorbs heat, the liquid refrigerant in the heat pump converts to
Why to
gas,
use
then to
biodiesel on
hot water
Heriot Watt
storage where it
University?
loses the
There are
energy
multiple
and
reasons,
returns
and the
to
major are that it has a good energy balance, it's cleaner with 78%, it's cleaner, and it lubricates the generator. There are two solutions in order to use biodiesel. We can either use the generators we have at the moment or get two new generators to work together for the demand.
The trigeneration system is when the heat produced from the CHP units is used to power an absorption chiller in order to generate chilled water for ACs or refrigerators. It has most of its benefits in the on-site generation. The use of such systems lead to around 80 to 85% of input being converted into useful energy. This leads to the production of heating, cooling, and power in one plant instead of 3 different plants. The process also makes use of multiple types of natural gas such as biofuel and hydrogen fuel cells. In terms of hydrogen fuel cells, the hydrogen and oxygen react with each other to produce electricity, water, and small amounts of heat, which is then used to generate the above.
Energy produced by VAWT and PV solar panel passes through a hybrid controller and to battery for storage. From there, hybrid inverter converts DC to AC, connecting to university meter output for utility usage. Rest of them, after doing the cost analysis, solar panel installation is the highest and CCHP being the lowest. We can get return on investment in around 5 to 8 years, calculated by total cost divided by the energy yield into the DEWA electricity unit price in dirhams. The final result is the total energy which is generated is around 322,000, which is around 20% of the total energy requirement by the university.
It's absolutely not, but under service in the long term, and that's what matters.
100% I agree, but we should all know a transition to clean energy is about making an investment in a future and to make Earth a better place to live in.